Unit 2, Learning Target Number 3. Use inverse operations to solve one-step subtraction equations. Solving subtraction equations is almost the same thing as solving addition equations. We follow the same three rules. Remember, our three rules were, number 1, get x by itself. Number 2, we're going to use inverse operations. And number 3, whatever we do to one side, over here, we have to do the same thing to the other side over here. So let's get started with our example. Right up here we have x minus 7 is equal to 15. We want to find out what x is. So naturally we have to get x all by himself. We have to get x all by himself. And to do that, what can we do? Well, currently we're subtracting 7. So what we want to do is use the inverse operation. We want to add 7 to it. Once we add 7, then x will be all by himself. So here you can see x minus 7 is equal to 15. If we add 7 to it, then basically we get rid of this subtraction of 7. If it's x minus 7 and we add those 7 back, then we get x all by itself. Now the problem again is, once we get rid of that minus 7, x is no longer balanced with 15. X is not equal to 15. X minus 7 was equal to 15. So we've gotten x by itself, we've used our inverse operation, but now we have to, whatever we did to this side, we have to do to this side also. Since we added 7 to the left-hand side, we also have to add 7 to the right-hand side. And that gives us x equal to 22. And if we want to check that, we can check it very quickly. We'll substitute 22 here in for x, 22 minus 7, and is that equal to 15? Why, yes it is, because 22 minus 7 is 15. That's equal to 15, so we have got it. Here are a couple more examples. Let's try these. Again, first thing we want to do is get x all by himself. So we have to use our inverse operations. What is the inverse of subtraction? It is addition. So we will add 11 to this side. And x minus 11, with you add 11 back to it, gives us x all by itself. Then whatever we do to the left side, we have to do to the right side. That's our final rule. So we'll add 11 to this side, and that will give us 35. So x is equal to 35. Is that correct? Let's see. We'll substitute 35 back in for x. 35 minus 11 is equal to 24. And yes, of course it is, because 35 minus 11 is 24, and this is equal to 24. We've checked it. Finally, we've got this one down here. Once again, we're going to get x all by itself. To do that, we have to use our inverse operation. The inverse of subtraction is addition. We're going to add 7 there to get our 0. We cross those out, and that will give us x is equal to, on this side, whatever we do to the left, we have to do to the right, plus 7. 7 plus 1 is 8. That gives us x equal to 28. Now let's check our answer. Substitute 28 back in for x. 28 minus 7, and that is 21. So we know we're right. Let's do some problem solving using subtraction equations. So first of all, there were 14 guests at Janica's birthday party. Each guest had one piece of cake, so one piece of cake per guest. And there were 18 pieces of cake left over. How many total pieces did the cake have? The first thing we're going to do is write an equation and then solve the equation. So let's see what we can find out. Number 1, we know there were 14 guests at Janica's party. We don't know how much cake there was, but we know that each person had a piece of cake. So we know there was a big cake, and we know that 14 people took some of it. So 14 people, and what was left over was 18. So we had a big piece of cake, 14 people took some of it, so they subtracted from it, and that left us with 18 pieces. Now if we just replace this with a variable, we've got our equation. So x minus 14 is equal to 18. The whole cake minus the 14 guests' pieces left 18 pieces left over. So let's solve it. X minus 14 is equal to 18. We have to get x all by himself. To do that, we use our inverse operation, which is addition. So we will add 14. That will give us 0 on this side with just x. So x plus 0 leaves us with x. Then whatever we do to the left side, we have to do to the right side. 8 plus 4 is 12. Carry your 1, and that leaves you with 32. And we'll check our answer just to be sure. 32 minus 14 is equal to 18. Is that true? Well, 32 minus 14, can't get 4 from 2, so you've got to borrow 1 from here. And that gives us 8 on this side. 2 minus 1 is 1. And 18 is equal to 18. And we've got it.